critical that the dimensions of the components are accurate, and we're not just looking at dimensionally. If we scan across the surface, once the waviness level starts to increase, we know that the life of that tool is coming to an end. So if we know that the tool is coming to the end of its life, we can automatically, without user intervention, call up a sister tool.
Welcome to the MTD podcast. I'm Giovanni Albanese, hosting today's show, a passionate engineer and a very proud member of the MTD team. Today I'm really excited to be at one of the most innovative and forward-thinking companies in the world, Renishaw, and we're at the global headquarters in Gloucestershire. Today we will be focusing on one of many technologies that they offer, the innovative SPRINT technology, a technology that could possibly transform your manufacturing processes. I have the privilege to be joined by two special guests and excellent engineers. So firstly, I'm joined by Justin Walford, Principal Product Marketing Engineer. Welcome to the MTD podcast.
Hi, Gio. Thank you.
Thanks for being on the podcast, and I'll come back to you shortly to talk to you about your career. And secondly, James Watson. This is the second or third time now you've joined us on the MTD podcast. Key Account Manager for Renishaw. Welcome again to the MTD podcast.
Thanks, Gio. Great to be here again.
How are you?
Very good, thanks.
Well, today I'm really excited, as I've already mentioned. I hope that's coming across, and I hope the listeners that are listening to this podcast really learn something about this new innovative technology. But before we start discussing the Sprint, Justin, could you kind of give our listeners a little bit of an indication about your background and how you got into engineering and a bit about your career?
Very good. So, I've been doing, I would say, measurement all my life. So I started off in the sort of geomatics domain, in technologies responsible for more or less for map making. But the last 10 years, I've been working with Renishaw in the industrial metrology sector, and I've been involved with the SPRINT on-machine contact scanning probe since we launched it, actually, just under 10 years ago. So I'm primarily responsible for looking after the marketing aspects of the technology and understanding where our customers really want to use it, how they can best use it, really, to gain manufacturing advantages in manufacturing, really.
And for the listeners listening to this podcast, we will be going into all of the details of the Sprint and what the product can do shortly. James, again, can you just give our listeners a little bit of detail about you and about your journey in engineering?
Sure. So I joined Renishaw coming up to 15 years ago now. I started as an operator and production engineer in manufacturing. So I've been at the sort of sharp end of machine tools previously, but then I spent the best part of 8 years in applications, and that's when I really got my hands into Sprint. And I was a team leader in an applications team within the Sprint side of the organisation. And more recently, then I've moved into the commercial side of the organisation, where for the last 4 years, I've been looking after key accounts in the UK.
I mean, Renishaw, I've met you at many open houses. You've got such a large portfolio of innovative products, and the majority of end users in the UK and around the world are now using them. But today, we're focusing on the Sprint. So can you tell us what the Sprint is?
Yeah, well, Sprint technology it's a high-speed scanning probing system, and it takes three-dimensional scanning data with high density, and it can be used in production environments for a wide range of applications, and we'll go into some of these in greater detail later on. Fundamentally, what we want to do is drastically improve production processes and reduce manufacturing costs for components.
Right. Okay. Now, who's already using this technology?
We've got a lot of users, actually, across a wide range of industries, from aerospace to automotive, the power and energy sector, and latterly we're starting to gain interest even from the medical sector. But even though we've also got users outside of those sort of classic big fields, so there's a big diversity of a user group.
Now, this product's been about for 10 years, as you've mentioned. Why is it such a beneficial technology, in your opinion?
The technology can really radically change how customers manufacture parts on the machine. It can help reduce scrap, We can help increase throughput. We can enable new, faster checks within the machine to ensure that the production process is still good. And that helps our users to ensure parts are coming off the machine good before they go on to, say, onto the CMM for, say, final inspection.
So how is this possible?
Well, a lot of it's in software, of course. We've got a huge variety of software tools that over the last 10 years we've been developing to tailor the Sprint system to multiple different applications for our end users. And the more work we do with Sprint, the more we uncover new, innovative ways of applying the technology. It's really easy to use. We've got some user-friendly programming techniques that's very similar to using CAD/CAM software, for example, and a lot of users will be familiar with those. But we can also support simpler applications with just G-code programming. So in the same way that you would normally use a touch trigger probe at the moment. So the
Sprint technology is effectively integrated into your machine tool and integrated into the process.
It is. It's fully integrated. The Sprint system is integrated into the machine tool, and it uses feedback from the control as well as the 3D deflection data from the probe to give you true representation of the surface that you're measuring.
Okay, so let's start at the beginning and let's talk about some of the different industries and some of the applications that it really lends itself to and the kind of people that would benefit from this new technology, and maybe they're not already using this technology, but it could be a game changer for them. So, let's start with you, James. Let's go through some of these industries and applications.
Sure. Well, I suppose you've got to start at the beginning, really, and one of the fundamental ways that Sprint can improve production processes for our customers is by reducing setup times. So reducing the cycle time within a manufacturing process where you're using a probe. By gathering data at a really, really high speed and high density of data, we can do some of those tasks that perhaps were adding to the cycle time to reduce that right back down and make sure that we're being as efficient as we can on the machine at producing parts, good parts.
I mean, this is a podcast, so our listeners have really got to use their imagination, but this technology is effectively scanning parts within the machine. So, for example, 3D parts or very complex parts. Would that be a
correct? Yeah, we can with our probe actually we can scan a huge variety of parts and anything from simple prismatic features, saying that just involve measuring points, lines, arcs, and circles, to slightly more complex features like cones and spheres and cylinders. We can measure the form of those, not just we can measure the position, the form, circularity, flatness. We can measure all these types of features on different shapes, and even on more complex, free-form surfaces. We can use the probe to scan those and do lots of wonderful things. Actually,
so I'm thinking, a component in the aerospace industry, castings and castings with variants. Would this be a good application?
Yeah, that's one classic example that we can apply technology. So large castings can often have precision features on the side of them, mating parts basically, that need to be machined to a tolerance and then often faced off, and they have large burrs on the edge that need to be removed. Traditionally, that might be done by either manually, which can be very time-consuming. We've seen cases where people have tried more advanced applications and use robots, but actually we can do all this with the Sprint system inside the machine tool. So we can actually scan these precision features once they've been faced off and then generate a toolpath to actually automatically do the deburr.
I mean, when I was on the shop floor, the problems I incurred manufacturing castings in the aerospace industry were phenomenal. The scrap that we used to produce, because of the variance of the castings and the setup times, were astronomical. I could have done with this technology back then. James, let's start looking at savings and different industries. And I've just mentioned setup time. Does this lend itself to the setups as well as the kind of stable process? Can you go through it in a bit more detail and explain?
It lends itself to the setup in multiple ways. And I'll hark back to what you said about castings. Is quite often with some complex freeform shapes, when you put them onto a machine tool, you don't have a prismatic feature to measure in order to be able to understand where it is. So by using Sprint, you can then take a large cloud of data, which then allows you to align it better. Even when we go back to prismatic features, and when I talk about prismatic features, I mean things like circles and lines and planes, traditional features that we can easily measure. Even when you want to measure those with Sprint, we can reduce dramatically the cycle time taken for those. So if you imagine you want to align a coordinate system to the center of a bore, for argument's sake, it might take you 15 to 20 seconds to take 4 or 5 points around that circle and update that coordinate system, and you've only got 4 or 5 points. Whereas with a Sprint system, you can probably scan that in less than 5 seconds, 4 or 5 seconds, and you've got probably up to 1,000 points that you've taken from there. So we're really combining this idea of high-speed scanning and high-speed data capture with more data. And more data gives us more information about the part and in ways that we can understand it.
Yeah, I was just going to take that point one step further. And we are starting to see quite a lot of applications where customers want traditionally to collect lots of touch trigger points, which is obviously very time consuming and really comes at a bit of a price because you'd rather be using the machine to cut parts. So, we are seeing, examples of, large blades, etc., where customers want to measure, quite a high number of points, and by switching to the scanning probe, we can really knock the cycle time down and improve the process in terms of speed.
So you're creating a stable process, and what you're alluding to, and correct me if I'm wrong, is that if you're currently using trigger probes for your processes and within your manufacturing facilities, this could be a fantastic transition into the next step of kind of products from Renishaw that will ultimately improve your efficiency and productivity.
Exactly. We've got quite a few applications where we've just dropped Sprint in where touch trigger existed before, because and the primary driver behind that was reducing cycle time.
And in them scenarios, what were the typical kind of time savings, in a percentage form?
Typically, if you've got an existing process that's based on touch trigger, obviously it depends on how much data you're collecting. The more touch trigger data you are collecting, then obviously the more cycle time saving reduction we will get if we switch that to scanning. Because our scanning probe, because of the integration into the machine, as James mentioned earlier, we are extracting those machine positions from the machine and mapping those with the probe deflection data. That gives us the center data. But not only does that give us accurate tip center data, it allows us to run at some pretty high feed rates on the machine. We can actually scan up to F15,000 on the machine. Now that's really impressive. As far as we're aware, we're not aware of anything else on the market that can scan that quickly. But that high feed rate and that high density data means you can do all sorts of things, basically, not just simple things, but complex things like adaptive machining.
So we're talking big savings, big savings, not just small savings. Now, one thing that I've been thinking about, do the savings increase if you were applying this technology on a 5-axis machine, for example, over a 3-axis machine?
So the great benefit of the Sprint system is that we can apply it to a really, really broad range of different types of machine tools. And a 5-axis machine, what it gives us is additional access to features. In the software, because we've fully integrated with the machine tool NC controller, we can actually get access by using the 4th and 5th axis to various different features, and then we can sort of untangle that in machine space from various different coordinate systems and different orientations of the part and stitch it back together to give us a true picture of the part that's on the machine. So that's really important when you're talking about things like blades. If you've got a blade or a blade on a blisk that you need to measure, you won't be able to access the entire perimeter of a cross-section of that blade. You need to position the rotary axes in order to get access for the stylus to get in and scan those various different patches. So 5-axis technology does increase the capability of the Sprint system, certainly.
It's very interesting. And now Renishaw always practice what you preach. I mean, the innovations that have been coming from Renishaw over the years are phenomenal. So I would assume that this technology is stemmed from your own machining practices and processes and ways in which you've looked to improve them, hence designing this Sprint technology.
It's even more than that. It's come from knowledge of what our customers are trying to achieve. So it stems from the fact that, over years and years, we've understood what our customers need and what they can't achieve. So there may be applications which touch trigger probing has been prohibitive to the process because it's added cycle time to an already time critical component in a manufacturing process. Sprint technology removes that to an extent because you can capture data so quickly on it that it's now become possible to measure components on your machine.
Not just about the measurement capability, actually, the probe itself can offer such a diverse level of capability. We've got a little macro cycle called machine health check. And that operates a little bit like some of our other calibration equipment that we offer. Users familiar with our bull bar and axis set systems. We can actually use the Sprint probe in a fairly similar fashion, albeit in a very quick fashion, on the machine in an automated way prior to cutting parts. So we can actually, by measuring a sphere or basing the probe into a small cone on the table and rotating the table, we can actually check the linear and rotary axes on the machine prior to carrying out any machining. So that can be done in a matter of seconds. And as a very quick sort of go, no-go check. And then, obviously, if it fails, then we would recommend that you move on to the bull bar and axis set and then thoroughly check the machines. But having that automated, rapid check before you're about to machine what could be a very expensive part, you've already spent many, many hours machining already, and you just really don't want to risk.
So you're not only getting the benefits that we've already discussed, you actually can calibrate your machine tool as well.
We can, we can't calibrate the machine, but we can check the machine.
And the machine kinematics.
Yeah, we can check the machine kinematics and then automatically instruct the process to stop so that the machine can be checked. Basically protecting the part, basically, before you carry out any subsequent machining that invalidate the part, basically.
And once you start machining a part, and maybe you're leaving excess material on that part before finishing the part, and to ensure that you've got material in the right places, for example, can it change the program? Or does this still need to be done manually? Or how does that work if it's integrated with the machine?
You can change the program in a variety of ways. So as with a lot of probing systems, touch trigger probes that you can use on machine tools, we have the ability to influence tool dimensions, work offsets, rotations within the machine. So we can make minor adjustments to the parameters in the machine to make sure that the final cut is also correct. But also we have the capability with Sprint to adapt the toolpath itself. So if we want to make sure that the cutter follows a certain path, for example, when you're deburring or chamfering an edge, then you can adapt the machine toolpath then to follow that profile correctly.
So this is fascinating, really. We're discussing lots of different applications and we've mentioned the aerospace industry, we've mentioned 3D parts. What other industries or applications, does it really lend itself to where you can see significant gains?
Difficult to say any particular industry. We've found different applications for Sprint technology across multiple sectors and multiple industries. And that just doesn't just include aerospace. It includes automotive, including EV manufacture. It includes power and energy generation, and we're starting to get a little bit of interest from things like medical components, where the components are, it's critical that the dimensions of the components are accurate, and we're not just looking at dimensionally the component, although we are able to scan the surface for mismatch between tools and things like that, which is highly important. But we can also check the condition of the surface.
Surface finish?
Yeah, well, surface condition. We're looking at waviness fundamentally. What that allows us to do
What does that mean then, James? Not what does it do?
Waviness it gives us a good indication of the quality of the tooling that we're using. If we scan across the surface, once the waviness level starts to increase, we know that the life of that tool is coming to an end. And fundamentally, what that means is the surface of the component is deteriorating, and it's likely that it might be a non-conforming part by the time it comes off the machine. What that allows us to do is implement sister tooling. So if we know that the tool is coming to the end of its life, we can automatically, without user intervention, call up a sister tool of the same specifications to then continue machining that component, or machine all the subsequent components with that new tool.
So James, this effectively is automation. You're automating your manufacturing process. By being able to have that sister tooling, if your carousel was big enough to accommodate for all them tools. And I'm assuming then that there'd be many applications within the automotive industry.
Yeah, there are actually. We've got quite a few customers in the automotive industry that Sprint lends itself very well to. So if you think about certain surfaces and certain features that are common in automotive components, sealing faces, bores, things like that, we can take an awful lot of data to understand that surface. If you're looking at a sealing face, by taking a number of touch trigger points on a surface, there's no guarantee you're catching the high and low points on that surface. So by scanning that face, you can then work out where the high point is, where the low point is, and if you need to refinish that surface flat, the minimum amount of material that you need to take off. If you're looking at bores, we can look at the circularity, we can look at various different properties and form of that feature, and look at how we can re-engineer those if they need to be. But what fundamentally we can do with the machine tool is, because it's fully integrated into the system and we know true surface points, because we know tip center data for that sprint probe, we're able to get accurate dimensions and accurate positions for various different features on that component, and we can capture that data very, very quickly.
So effectively what you're telling me is that this automation, effectively you're integrating the sprint into the process. So because it's so fast now, it can come out and every so often it can do a check, if you like, which then would kind of inform and give the machine tool data, keeps all components to mid-tolerance, and creates a stable process, whether you're doing high volume work or potentially low volume work as well.
And a stable process is fundamental to automation. So, the Renishaw product, although it's not the whole solution to automate a process, it's a great enabler for it. And that's really, really important. And it's not a tool that needs to be just for the larger companies. There may be some smaller companies out there that can benefit from the technology, particularly when they're doing a lot of repeat work that's of similar types of work, and they're running through hundreds and thousands of the same components. There could be some huge savings.
Well, like I just mentioned to you earlier, when I was in the aerospace industry, we used to do batches of 10, 20, but they would repeat every single month. And them castings or their irregular shaped parts were so problematic. The setup times, took ages. Every one was an individual set effectively, because you couldn't hold them all the same, So that op one was really problematic, and it would have lent itself perfectly to them applications for sure. Automation is massive, but is it also kind of simplifying the process?
Yeah, I think we are. That's one of the key benefits of the technology we offer, is that there is a big variety of software that we can provide with the probing systems, and not just about having a very capable 3D probe, but it's the software that we wrap around it that gives the real capability and advantages to the customer in their process, in controlling the process in however they need to, basically.
And how important is it to simplify a very complicated process? I mean, complexity of the components seem to be getting more complex all the time. The skill levels seem to be is a problem and an issue. So, how important is this technology to simplify the process?
As I think James alluded to earlier, the software comes at various levels. So if you've got users that are familiar with G-code, macro programming, then quite a bit of functionality can be measured through that programming method. But we've also got a CAD-CAM style system that allows users who are familiar with CAD-CAM already to basically import a model, have some defined geometry on that model, which will specify the scan toolpath along the part. the users can very quickly, using our tools, select that geometry and convert that geometry into a scanned toolpath and a program, post that onto the machine. And to be honest, in a matter of minutes, you can now program quite a complex toolpath. We've simplified the programming to such a level that it's very user friendly.
It's not just the programming of it as well, it's the day-to-day operation of the system. When we're talking about the complications of availability of skilled operators and things like that, if you've used the Sprint system or a system similar that can then automate the process of finding your part or adapting your machining to it, there's no longer the requirement for that one skilled person that knows how to set that job up over and over again. We're automating the process of ensuring that the parts are correct when they come out of the machine tool.
And that is the old objective, isn't it? It's making correct parts in the fastest possible way possible. Yeah. And staying on the theme of automation as well, and going back just one step to kind of the sister tooling, automation is massive, I believe, for the UK to become competitive, not just in the UK amongst ourselves, but globally. And everyone is looking to automate and run 24/7. It is a key feature to be able to run your machine 24/7, isn't it? By having that technology within the machine and being able to know when the tools need changing, or if there was a problem and something's caused vibration. It's kind of, you've got that reassurance that and quality
we've seen
control.
Quite a few cases of customers wanting to go for that sort of lights out process, closed loop processes basically, and technologies like Sprint and many other technologies we have in Renishaw can enable that sort of end-to-end process that needs very little intervention during all the stages of manufacture, and that's probably, really key.
That's a key point, end-to-end processing. Yeah. That is probably rounded it up perfectly, isn't it?
Yeah, I'd say that's the goal really, is to have a manufacturing chain that you're confident in from start to end, and Renishaw offers a variety of technologies to support every stage of that process basically.
And just to summarise really, and if you were to be selling this solution to me, what would be the ideal application for this technology?
I don't think there's one ideal application. We've seen such a vast variety from small parts to large parts to high volume parts to low volume parts. The benefits are really diverse, from increasing throughput, saving scrap, automation. There's not one, let's say killer application. There's lots of killer applications for on-machine scanning for sure.
There are. I mean, it's manufacturing variation that creates the requirement to control a process, and that can come from a variety of different sources. It can come from variations in the part supply, it can come from variations from temperature control on the machine, it can be coming from all sorts of different areas. Because with the Sprint technology, we can basically get a huge amount of data in a short period of time. I've said it over and over again in this podcast, but it means that the opportunity to apply Sprint is there in almost every industry and with almost any user.
Opens up new ways of doing things.
It's thought-provoking for sure. I mean, I've just read a quote on the wall prior to us doing this podcast. We need diversity of thought in the world to face new challenges, and that was from Tim Berners-Lee. Exactly. So I think that sums it up quite nicely, really. I think, Renishaw, for our listeners, I'm sure everyone's aware of Renishaw, all of the technologies or most of the technologies that Renishaw offer, but the Sprint, maybe you might not be familiar with this technology. There's a really nice article in the MTD magazine on Sprint technology that I would strongly recommend you take a look at and read. We're also going to be releasing some videos soon on the Sprint technology, which will give you a nice visual example of what we've been discussing in today's podcast. Guys, it's been an absolute pleasure being here today and learning from you both. Any last thoughts or any last things that you'd like to say to our listeners before we wrap this one up?
Well,
after you, James. I
think we've summarised it quite well there, but exactly what you said, Gio. Anybody wants to know more information about Sprint, there's that great article in MTD, which is the January issue this year. And also there's loads of information on our website. So if anybody's interested in this sort of technology, then by all means get in touch with your local representative to talk about it more. We can give you demos and examples.
So there you have it. Thanks, James. Really appreciated your time today. Justin, it's been an absolute pleasure and great to meet you again. Fantastic podcast, fantastic technology, fantastic facility here at the Global HQ at Renishaw. We hope that you've learned something and this podcast has been educational. Until next week, the MTD podcast.
Thanks for listening to the MTD podcast. If you found value in this episode, please subscribe and leave a rating and review. Find more episodes on mtdcnc.com.